The mission that gave humanity one last look home. Imagine a spacecraft that has been traveling away from Earth for almost half a century. Its cameras once showed us Jupiter's storms, Saturn's rains, and strange worlds we had only imagined. But today, those cameras can never take another photograph. That was not an accident. NASA deliberately ended Voyager 1's ability to take pictures because the spacecraft had reached a point where every bit of electricity mattered. And before the cameras were shut down, Voyager performed one final visual act that changed the way humanity sees its own home. From billions of kilometers away, Earth became almost nothing more than a tiny point of light. This is the story of how that happened, why NASA had to sacrifice the spacecraft's eyes, and why those final images became far more important than anyone expected. Voyager 1 left Earth on September 5, 1977. The spacecraft was designed during an era when computers had tiny amounts of memory compared with even the simplest modern devices. Yet Voyager carried an extraordinary advantage. The planets were arranged in a rare configuration that allowed a spacecraft to use their gravity as a series of natural boosts. Instead of carrying enough fuel to accelerate itself all the way through the outer solar system, Voyager could pass near a planet, exchange energy with that planet, and use the resulting change in speed to reach its next destination. This technique is known as a gravity assist. It sounds straightforward when described in one sentence. In reality, guiding a machine through billions of kilometers while using the gravity of several planets required astonishingly precise navigation. Voyager 1 reached Jupiter in 1979. The encounter transformed our understanding of the giant planet. Its cameras revealed the Great Red Spot in extraordinary detail. They also showed that Io was covered with active volcanoes, making it one of the most geologically violent worlds known in the solar system. Europa presented another surprise. Its surface was covered with cracks and ridges that suggested something remarkable could exist beneath the ice, a hidden liquid ocean. Then Voyager continued toward Saturn. When it arrived in 1980, Saturn's famous rings were revealed to be much more complicated than they appeared from Earth. What looked like a few broad bands became a maze of ringlets, gaps, structures, and gravitational interactions. Saturn's moon Titan also became a major mystery. Its thick atmosphere prevented Voyager's cameras from seeing the surface clearly, but that limitation itself was a discovery. Voyager 1's planetary tour was essentially finished after Saturn. Because of the geometry of its Saturn encounter, the spacecraft was sent onto a trajectory that carried it away from the main plane of the planets. Voyager 2 continued toward Uranus and Neptune. Voyager 1 took another path. It was heading outward. Away from the familiar planets. Away from the bright worlds that had filled its cameras. Toward the enormous darkness beyond the outer solar system. For years, Voyager 1 simply continued traveling. Its radioactive power source was slowly becoming weaker. The spacecraft used radioisotope thermoelectric generators, which turned heat produced by radioactive decay into electrical power. The process is dependable, but the available power declines over time. That meant NASA engineers had to make increasingly difficult choices. A modern spacecraft can often run several systems at once. Voyager could not. Its engineers had to think in watts. A heater that consumed a small amount of power could matter. An instrument that no longer served the main mission could become a luxury. And the cameras, which had already completed their primary planetary mission, were eventually going to become one of those luxuries. But before that happened, an unusual idea appeared. Planetary scientist Carl Sagan had been arguing for years that Voyager should turn its cameras around and photograph the planets from the outside. The proposal was simple to describe and difficult to execute. Instead of looking outward at another world, Voyager would look back toward home. The result would become a kind of family portrait of the solar system. There were serious objections. The cameras had been built for the outer planets. They had not been designed for a casual look toward the sun. After more than a decade in space, their hardware was old. Restarting equipment that had been dormant for years carried risks. There was also a scientific argument against the idea. From Voyager's enormous distance, the planets would be incredibly small. Many would be nothing more than points. Why risk an aging spacecraft for pictures that might contain very little detail? Sagan's answer was that the value was not about planetary detail. It was about perspective. For the first time, a machine built by humans would be far enough away to look back at the entire planetary neighborhood. And Earth would be included. NASA eventually approved the plan. The photography sequence began in February 1990. One of the biggest challenges was simply waking up the cameras. The imaging system had spent years exposed to the extreme environment of deep space. Engineers did not want to rush power into fragile components. The cameras were warmed carefully, with power introduced gradually. The team had to wait for confirmation that the hardware had responded. Commands had to be carefully prepared and transmitted across billions of kilometers. The spacecraft could not simply point a camera at a planet and adjust the framing after looking through a live viewfinder. Its targets had to be calculated in advance. The timing had to be right. The spacecraft was moving. The planets were moving. And the images would eventually show worlds that were tiny compared with the size of the camera's field of view. Every exposure was a carefully planned experiment. The first targets included the outer planets. Neptune appeared extremely faint. From Voyager's position, the sunlight reaching Neptune was already weak, and the reflected light had to travel an enormous distance back toward the spacecraft. The result was not a dramatic blue globe. It was a tiny, pale mark against darkness. Uranus was similarly reduced. A world that had once filled Voyager's cameras became little more than a faint point. Saturn was different. Even from several billion kilometers away, the spacecraft could detect the presence of its rings. But the planet was still only a small feature in the frame. Jupiter suffered the same fate. The enormous planet that had once dominated Voyager's images was now just a bright spot. That contrast revealed something profound. Distance can erase the visual differences between enormous objects. A giant planet can become a dot. A storm larger than Earth can disappear from view. A world filled with mountains and oceans can become a single speck. The farther away you travel, the less the eye can tell you about what an object really is. Some planets did not appear in the final family portrait. Mars was extremely difficult to capture from Voyager's position because of the combination of geometry, sunlight, and the weakness of the reflected signal. Mercury presented another problem. It lies close to the Sun, and pointing Voyager's sensitive imaging system too near the Sun created an unacceptable risk. Protecting the camera was more important than forcing a photograph that could damage it. Pluto was also too difficult to resolve with the available equipment and exposure limits. The missing planets were a reminder that the mission was not magic. The spacecraft had physical limits. Light had limits. Distance had limits. And Voyager's aging hardware had limits. Then the cameras reached Venus. The planet appeared as a bright crescent. And after the other targets came the most important object of all. Earth. Voyager was more than 6 billion kilometers away. At that distance, Earth was far smaller than a normal pixel-sized image of a planet. The spacecraft was not capable of resolving continents, oceans, cities, or clouds in the way a close spacecraft could. Earth was reduced to a tiny point. That point became famous as the pale blue dot. The photograph was not simply a normal snapshot. Multiple exposures were made through different color filters and later combined to produce the final appearance. Sunlight scattered inside the camera system also created bright streaks across the image. By chance, Earth appeared within one of those rays. The effect made the tiny planet look as if it were suspended inside a beam of sunlight. That accidental composition became one of the most powerful images in the history of space exploration. Think about what the dot represented. Every civilization built by humanity. Every language ever spoken. Every family. Every war. Every scientific discovery. Every childhood. Every city. Every person who had ever lived. From Voyager's distance, all of it occupied a point so small that the planet itself could not be visually resolved. The photograph changed the scale of the conversation. It was no longer only about what Voyager had discovered. It was about where we were. We often imagine Earth as enormous because it is enormous compared with our individual lives. But on a cosmic scale, Earth is tiny. The pale blue dot made that idea visible. After the photographs were completed, Voyager had done something extraordinary. It had looked back. But the mission was not finished. The spacecraft still had work to do. Voyager was entering an increasingly distant environment where its instruments could measure the transition from the Sun's influence toward interstellar space. Power had to be reserved for those scientific instruments. The cameras had already completed their purpose. And keeping them warm and operational required electricity. That electricity was becoming too valuable to spend on imaging hardware that would no longer be used. So NASA made a difficult choice. The camera software was removed from the spacecraft's available memory. The systems needed to operate the imaging instruments were no longer preserved as an active part of the mission. Voyager did not merely stop taking photographs. It lost the practical ability to operate its cameras. The heaters were also shut down to save power. The cameras became cold pieces of hardware attached to a spacecraft that continued traveling. The machine that had once shown us Jupiter's clouds and Saturn's rings had effectively lost its eyes. But that sacrifice helped extend Voyager's scientific life. The few watts recovered from unnecessary systems could be redirected toward